In this introductory lesson on electricity, we will look at what electricity is and how it can be produced. In order to understand how electricity works, we first need to examine the atom. Atoms are the smallest particles that an element can be divided into. All materials are made up of atoms. Each atom consists of a nucleus, made up of protons and neutrons, which is surrounded by electrons. Although not entirely scientifically correct, for the purpose of this explanation, we can assume that the electrons orbit the nucleus like planets spinning around the Sun. Each proton in the nucleus has a positive electrical charge. The neutrons have no electrical charge, and for our purposes they can be ignored. Each electron has a negative electrical charge. Each atom has an equal number of protons and electrons. Their electrical charges cancel each other out, so an atom is electrically neutral. Atoms of different materials have different equal numbers of protons and electrons. A fundamental fact about charged particles is that particles with unlike charges attract each other, but those with like charges repel each other. The negative electrons are held in orbit by their attraction to the positive nucleus and their repulsion to each other. Electrons in the outer orbits of an atom are not so strongly attracted to the positive nucleus, and may easily fly off and attach themselves to a neighbouring atom in the material. These loosely attached electrons are known as free electrons. An atom that has lost an electron becomes positively charged and is called a positive ion, while an atom that has gained an electron becomes negatively charged and is called a negative ion. Materials which have easily detached free electrons in their outer orbits are called conductors. Metals such as copper, silver and aluminium are good conductors. Materials which have very few free electrons are called insulators. Wood, rubber, glass and plastics are examples of insulators. If the free electrons are made to move in a particular direction through a material, this movement is known as an electric current. Electrons are caused to move through a conductor by applying a positive charge, which is a deficiency of electrons, at one end of the conductor, and a negative charge or surplus of electrons at the other. The positive charge attracts the free electrons, and the negative charge repels them. So there is a flow of electrons in one direction through the conductor from the negative terminal to the positive terminal. This flow is known as an electrical current. To maintain the current flow, the force which caused the electrons to flow in the first place must be maintained. Otherwise, when sufficient electrons have flowed from the negative to the positive terminal to balance out the charge, the current flow will cease. To keep the current flowing, the source of the force which caused the electrons to move must be capable of absorbing the electrons from the positive terminal and transferring them through itself back to the negative terminal. In this way, the current can be maintained as long as there is a complete circuit. Electricity was in use before electrons were discovered, and it was assumed that electricity was the flow of something from positive to negative. This is known as conventional current flow. Many of the laws of electricity are based on this idea. As we now know, electrical current actually consists of electrons flowing from negative to positive. This is known as electron flow. There are 6 basic means by which a force can be provided to cause electrons to flow. These are friction, which produces static electricity, by chemical action in cells and batteries, by magnetism using alternating current or direct current generators, by the application of heat to thermocouples, by light in photoelectric cells, and by applying pressure to piezoelectric crystals. Of these 6 methods, only batteries and generators produce electrical power in usable quantities. These 2 methods will be explained in detail in later lessons. We will have a quick look here at the other 4 methods, starting with static electricity. When 2 materials rub together, some electrons can be transferred from one material to the other. The result is that one material will have a positive charge and the other a negative. This is known as static electricity. Quite often, this build-up will discharge with a spark when the 2 materials are moved apart. You may have observed this when taking off a sweater. This phenomenon can cause problems when an aircraft is being refueled. The flow of fuel through the equipment can cause a build-up of static electricity and the possibility of a spark, which could ignite the fuel. To prevent this, the aircraft and the fuel truck are bonded to each other, and each is bonded to earth to prevent the possibility of a static discharge when connecting or disconnecting the refueling equipment. When 2 wires composed of suitable dissimilar metals are joined at both ends, and one of the ends is heated, there is a continuous current which flows in the circuit. The device which uses this phenomenon is known as a thermocouple. The 2 connections are known as the hot junction and the cold junction. The amount of current flow is directly proportional to the difference in temperature between the 2 junctions. Thermocouples are often used to measure the exhaust gas temperature of a jet engine, where the hot junction is placed in the exhaust gases and the cold junction is contained in the gas temperature gauge. When pressure is applied to a crystal of a suitable material, quartz for instance, the free electrons in the crystal move together on one side of the crystal. This produces an electrical charge across the crystal. These crystals are known as piezoelectric crystals. Piezoelectric crystals may be found in modern headset microphones. Finally, certain materials gain an electric charge when exposed to light. Components containing these materials are known as photoelectric cells. Photoelectric cells may be found in some smoke detectors. That is the end of the lesson. Here is a summary of the important points. Copper, silver and aluminium are good conductors of electricity, while wood, rubber, glass and plastics are examples of insulators. In an electrical circuit using conventional flow, the current flows from the positive to the negative terminal, but electrons actually flow from the negative to the positive terminal. An electrical charge can be produced by friction, by chemical action in cells and batteries, by magnetism using generators and alternators, by the application of heat to thermocouples, by light in photoelectric cells, and by applying pressure to a piezoelectric crystal.